Sirefef, referenced as Zero Access or Max++, has entrenched itself in the cyber world since 2011 as a prolific multi-component Trojan and rootkit. Its primary function is the establishment of a peer-to-peer P2P botnet, specifically designed for facilitating click fraud and crypto mining operations. Known for its stealthy behavior and unwavering persistence, Sirefef holds the notorious ability to dismantle security mechanisms, making it a significant threat to systems worldwide. The architecture of Sirefef is multifaceted, comprising a dropper, kernel-level rootkit, and user mode payloads. This thoughtful composition allows it to evade detection effectively. Utilizing kernel driver patches or alternate data streams (ADS), Sirefef exists below the usual radar of conventional security solutions. The decentralized nature of its botnet, empowered by obfuscated P2P communication protocols, adds another layer to its operational security, as it continuously adapts to evade authorities. The three variants of Sirefef reveal varying roles in the broader framework. Variant A serves as a persistent backdoor, employing kernel-level techniques to layer the system with hidden DLLs and bypass security checks at boot. Variant B takes on the function of a dropper, using exploits or bundled Trojans for installation, often erasing its traces post-install. Meanwhile, Variant C, the web redirector, operates by injecting malicious code into legitimate processes, expertly hijacking search results and perpetuating download chains for further malware distribution. Persistent strategies adopted by Sirefef include KEOM hijacking to modify registry keys for malware launch during startup, and kernel rootkit tactics that patch drivers to ensure stealth. Additionally, this Trojan adeptly neutralizes security tools by deleting essential services like Windows Defender and altering access control lists, ACLs, to hinder antivirus capabilities. In a bid for discretion, it often conceals its components within innocuous file names in the recycler or utilizes ADS. Infection vectors are varied, including deployment via other malware like knickers, exploit kits such as Black Hole, and malicious advertising campaigns. Users may unwittingly install Sirefef through pirated software or deceptive tools. The indicators of compromise, IOCs, are stark. Unusual CPU or memory spikes, disabled security services, and the discovery of peculiar files named I and N lurking in hidden directories serve as telltale signs of infection. Knowing the artifacts, specifically file paths and modified registry entries, can enhance detection efforts, aiding in the battle against Sirefef's advanced persistence and stealth techniques.